Welcome, I'm Kashlan Hall, and today we're going to explore the future of AI applications using OpenAI and SurrealDB. So, as Lizzie mentioned, I'm a machine learning operations engineer, and my role primarily revolves around building platforms that optimize workflows for data scientists and machine learning engineers. So these platforms, like you see on the screen in front of you, are really pivotal to our field. So building an MLOps platform, we use a whole host of tools and services that enhance and provide governance around our AI applications. And building a machine learning operations platform can be quite daunting. And there are many challenges with this. And this is even more pronounced when you're trying to integrate more advanced tooling that is offered by the likes of OpenAI. Now, this is where SurrealDB comes into play. I'm always looking for new innovations that can streamline our operations and the promise of having the complex logic right next to multiple models of data structures in the database was really intriguing for me. And over the last few years, not only the community has grown, the amount of features within SurrealDB has grown with it. And that's been equally as exciting. So tonight, we're going to explore one of SurrealDB's hottest features, I would say, and that is the vector embeddings and vector search that it offers, and integrating it with OpenAI. So I thought it'd be important before we get into the technical details of this project. I thought it'd be useful to talk about the brilliance and also the boundaries that LLMs offer. So I don't need to go into the brilliance too much because I'm sure everyone in this room has used ChatGPT at some point. For me, it's a great grammatical and spelling tool, as I'm not really great at English from school. But it's also allowed me to learn new coding paradigms while we're learning Rust, for example. However, ChatGPT and other LLMs fall short when it comes to very updated recent data. You give it a prompt and it gives you an answer back. And it generates this answer by learning from its patterns that it was trained on. Now, often at times, the response back to you can sound very truthful, and it's not able to evaluate whether the response back is actually accurate or not. And this is where hallucinations come into play. We want to try and remove these hallucinations if possible and have the most accurate results that we can when embedding these applications into business critical systems. So unlike databases or searches or a search system, it doesn't typically give you a reference of the source that it generated the response from. It could use its prompt, but that doesn't always align with very truthful, accurate data. So as you can see in the example on the screen, I've asked it for the most valuable player of the NBA, and it's given me that it's Nikola Jokic. And if you're an avid NBA fan like me, you know that this is incorrect, and it's actually Joel Embiid of the 76ers. Now I can't fault ChatGPT all for this because it's told me that it was last trained in April 2023, and so you can infer as a user that this information may be incorrect. And the MVP reward is typically given in each May of the year. I thought I'd throw this in because I found it quite amusing. I think ChatGPT has a favorite when it comes to the brothers of the co-founders of SurrealDB, as it's accurately named Jamie as the co-founder, but Toby, hopefully in the next training iteration of the ChatGPT models, you will be in the training corpus, so yeah. So how can we close this knowledge gap? Well, we could wait for OpenAI to retrain their models, but we have no control of when they would do that. We could also train a model ourselves, but that requires a huge amount of resources to do. So one way that you can solve this problem is by prompt engineering. So the answer to the previous question regarding the current MVP is actually, you can find that on Google by just searching. So let's say that we just got this information from Google and you stored it as a document somewhere. We can then engineer a prompt where you insert this answer, this context into the prompt, pass it to ChatGPT, and ChatGPT would reply to you with the correct answer. Now, as a user, this isn't very helpful because you already need to know the answer to your question. But it'd be great if you could have a service that would already do this for you, and as a user, you would have no idea what is happening behind the scenes. You just get your answer back. So that's where, in the field, it's been developed retrieval augmented generation, otherwise known as RAG, and this is what this presentation is going to be about using SurrealDB. So let's just have an overview of RAG for the people who haven't seen it before. So you have a bunch of your documents. Again, we'll use the MBA example. And then we want to be able to pass these documents through an embedded model. I'm not going to be able to go into details of this embedded model because of the time constraints to this presentation. It's a whole presentation in itself. But essentially, all you need to know is that you pass a string of text into the embedded model, and the embedded model returns to you an array of numbers, typically of fixed length, that has semantic meaning and context of that sentence. We then put the documents and the vector embeddings into a vector database. This vector database typically can perform advanced search queries to find relevant documents to a user's question. So here we have a user's question. It also goes through the embedded model, and then this embedding is used within the database to search for the most relevant documents that is stored within it. This typically is done by a distance metric like Euclidean distance, or a similarity metric like cosine similarity, where we're just comparing what vectors are the most similar to each other and try to get the most relevant document out of the vector database given a question. Next, we define a prompt. We engineer a prompt. With this prompt, we then take the relevant document, insert it into the prompt, and finally pass it into an LLM, like your ChatGPT interface, or one offered by OpenAI. And then that is able to use the prompt and the context to retrieve an answer for you. So that's where the augmented generation part of RAG comes into play. In this presentation from here on out, we're going to see how we can do a naive RAG system with SurrealDB and talk about what other features SurrealDB has already that you can advance your RAG system later on. So there are many ways to do sort of RAG operations and systems. That you can use tools like a popular library, LangChain. But I thought it'd be more interesting in this presentation to do everything fully within SurrealDB, as much as I can anyway. So first, we need documents, we need vector embeddings, and we need to insert them into the database to perform the retrieval part of our RAG. I've cheated here a little bit by not doing this myself and using a created dataset by OpenAI. The reason that I've used this dataset is because it's quite large with 25,000 rows, and I think it's about 1.7 gigs worth of data as a CSV. And it's often used to compare other vector databases against each other. So by having this available to the community, you could try out SurrealDB with the same dataset. You might try out another vector database. A typical row of this data looks like this. So you have your URL, you have your text, and you have your content vector, which is the vector representation of that text. So now that we have our data set, we now need to insert it into SurrealDB. When experimenting with SurrealDB, it's been great as I've been able to run the database locally, completely schemaless, with none of these types here, and just insert my records and iterate on my projects. But as the project evolved, it was really good to explore the type safety that insert in database has. So if you could look primarily at the title, the content vector having an array length of 1,536, and the URL, we're certain that it does have the structure of a URL, what we're inserting in. This comes into play later when we're embedding our question and making sure that we can perform cosine similarity. We're also defining an index here on our table, particularly on the content vector field. So we're stating on this field mtree with dimension 1536 and using the distance cosine to perform really efficient queries. I hope you can all see this from the back. This is a Python snippet. This is using the new Surreal SDK for Python, and it's got Rust bindings. So you don't need to know anything about Rust to use this Python SDK. All you need to know really is that Rust is handling the connections to the database for you, so you get that safety and performance there. But you're still able to write Python as you normally would. In this case, we're just connecting to the database. We're selecting our namespace and database that we want to use. We're reading in our data from a CSV file into a data frame, and we're generating a bulk insert query that we can insert multiple records into the database at one time. So at this point, we've got our records already in SurrealDB now. We now need to create the rest of our RAG architecture so we can augment and generate any queries that the user has. So I decided to do this with SurrealQL, just to give a flavor to the audience of what the capabilities are. We're just using SurrealQL within SurrealDB. So don't worry about the above function right now. We'll get into the details of that later. But this return function is the most important on this slide. So we're stating here in the SurrealRAG function that we want to use the GPT 3.5 Turbo LLM. And we're asking the question, what are the fixed yearly events in April? List all the days you're aware of. And we're also given a threshold here of 0.85. Well, that will come into play later. So this does look like a ChatGPT response. The SurrealQL interface just returns me a string. It didn't look very nice. I just asked ChatGPT to render this nicely for the presentation. So you just have to take my word that this is the response I got. As you can see here, that it's listed all the dates it is aware of. And at the very bottom, I'm not sure if you'll be able to see it at the back, but you've got a blue hyperlink of the title of the article that it retrieved this data from. So in comparison, just to show the validity of the first response, this is an answer that came from ChatGPT. As you can see, we've got much more content here. It doesn't list all the dates, and it goes into more details of the dates. So let's go through each of these functions one by one to hopefully make sure that everyone doesn't realize that it isn't magic. So I should have said on the previous slide, apologies, that we're using the text embedding Ada 002 model from OpenAI to embed our input vector, our input question, sorry. This model returns to you a fixed length array of floats, our vector embeddings of 1536. That was important because that is the same embedded model that was used in the dataset, and we want to make sure these vector lengths are the same to perform cosine similarity. So in this function, we are given the embedded model and also our user inputs. Now in SurrealDB, another great feature is that you can make HTTP post requests inside the database. So here, I'm just calling OpenAI's API, particularly the embeddings endpoint, and creating a post request, giving it the model and the inputs, and it returns to me a vector embedding of 1536. Now that we have this input vector, we can insert it into another function, search for documents. And we also give the threshold here as well. This is where the true magic of vector search comes into play and what we defined earlier on the table. So we're selecting our fields, and then in the where clause, we're using the index of the content vector to search for the top most similar document compared to the input vector using cosine similarity. Now we have an additional where clause here where we're performing cosine similarity then again, and getting that similarity metric back. And we're ensuring that it's greater than or equal to the threshold. This will become more clear later, but I thought it would be important to raise it now. Essentially, this query returns to you a record. If the record is empty, we return an empty string from this function. If the record is not empty, we then stringify the record. A happy path looks like this. So we've got the text, the full text of the Wikipedia article, we've got the title, and we've got the URL of that Wikipedia article. Now that we have the context document, we then use that within the getPromptWithContext function. Now, a prompt is essentially a set of instructions and guardrails that the LLM should follow when given a response. As you can see, there's a lot of detail here, but specifically, if you can focus on the third paragraph where we're stating, please add one markdown link using the format title URL and replace the title and URL with the associated title and URL of the more relevant page from the context. We're also stating to only provide one link and do not provide any other references. Along with that, we're asking the LLM to only reply with the context provided. And if we give the prompt an empty string, then please reply with, I'm sorry, I do not know the answer. And to further state that this RAG system is working, I'm asking the LLM very nicely not to use any prior knowledge that is being trained on. So as you can see at the bottom of the prompt, we have a HTML-like tags where we're finding and replacing the $context with our actual context that we provide this function. This looks something like this when you're providing the prompt to your LLM. So we're just inserting the record that we got earlier straight into that context tag. Next, we then provide that prompt to the LLM and get a chat completion, a response back. That again, very simplistic, is just another post request. So we're providing the model that we want to use, GPT 3.5 Turbo. We're providing the system role with the prompt that we just created, and we're providing the user role with the original input that the user requested. And again, we get the final response back of all of the dates with included the hyperlink at the end of the response. And just to prove that our prompt does work correctly, my name is actually also a Welsh village. I'm not named after this village, and there's nothing there, to be quite frank. But I knew that this would be a good example because it wouldn't be in the Wikipedia dataset. So you'll have to take my word for it again, but the RAG response gave me, I'm sorry, I do not know the answer. So this is just showing like some of the guardrails you can put in when the LLM isn't quite sure of the context and the question that the user has provided. So we've built a very naive, simple RAG here using SurrealDB and SerialQL. But I would like to state that SurrealDB already has features baked in that you could create more advanced RAG systems. Some that I'll point out here is that you can use SurrealDB as an in-memory state on the client side and store chat history and use your RAG system as more of a question answering chatbot and just keep the chat history for a session that the user might have. SurrealDB also has really good authentication, so you could easily put permissions on each field of your table and ensure that only specific users with access can access those embeddings and return to you those relevant documents. So this is really great if you have a very diverse set of users who can only access particular documents. SurrealDB has really good full-text search capabilities, and a lot of the vector databases out there either use other services or they've got something built in where you can perform a hybrid search, so using your traditional search mechanisms and also vector embeddings to create this semantic search layer that could potentially give you more accurate results for your application. The most exciting thing for me is that SurrealDB also offers relations and sort of graph-like data inside. So there's an argument in the community that you actually don't need embeddings and search at all, and that you can ask the LLM to construct a sort of graph like query for you and retrieve the relevant information from that graph. It's something that I'll definitely be experimenting, and maybe there'll be a part 2, hopefully, if SurrealDB have me back at some point involved in this. The reason that I decided to do this presentation in SurrealQL is because SurrealDB has SurrealML, where you can query the database and machine learning models within that database like you would any other traditional SQL query. And it'd be a really nice addition if you could have sort of a local small LLM and do it that way. So essentially replacing the post request earlier for a more of a select type of query statement. And personally, for me, the last 2 points are more of a wish list. It'd be great to have some more flexibility of inserting records. I know other database like services out there can import CSV data. That would be lovely as an ML practitioner for our data scientists. And also have user-defined environment variables that you can access through SurrealQL. I believe there's already issues on this in GitHub, so I'm hoping this just drives more towards that. And for this presentation, I've got a GitHub repo that provides all of the code and the examples that was used to build this presentation. So please feel free to use that and as a foundation to building more complex systems. This has been a really good experience. And yeah, thank you. And if there are any questions, yeah, please let me know. Thank you.
I realise you said it's a topic for a whole other lecture, the actual embeddings part, but can you say a little bit more about anything that distinguishes the embeddings that you're using and how Surreal helps that as opposed to all the other vector databases that are out there?
Yeah, sure. So I can do my best to answer that. So vector search really depends on the size of the vectors that you have. The larger the vectors, typically slower the search will be. So it really depends on your application that you're building. There are many open source embedding models out there from Hugging Face, for example, that have smaller vector embedding dimensions where you could potentially insert into the database quicker and also perform quicker inference on finding relevant documents. So yeah, there's certainly a case for choosing your dimension size is particularly important for your application depending on the amount of latency that you need. I hope that answers your question anyway.
Yeah, I was interested in a little bit more about how I mean, you said something about the comparisons in the vector size, but given that you have 1536, does that in fact slow the comparison down, or is there some way around that?
So what I've seen so far, the smaller the embedding, the faster the search in SurrealDB anyway, and I'm sure that'll be optimized in the future. But there's no to say that the larger the embedding, the more information the embedding will hold for your text. So unfortunately at this stage it's a lot of trial and error and looking at leaderboards of what works for your application. But yeah, that's from my experience anyway so far with it. Bigger is not always better when it comes to embeddings.
Could I ask you one other quick question? Have you seen any evidence for the hole in the middle problem? The hole in the middle, you know, things, RAG and other things, other LLMs can remember the beginning and the end, but everything in the middle gets lost. Do you have any experience of that? Does it work better than
so
that?
The stuff we worked on right now, we've just used OpenAI embeddings, and we haven't encountered that issue in particular. So it's definitely, I'm happy to discuss with you after this, because I'd love to learn more about that for sure.